and Dr. Chandrasekhar, Associate Professor, Department of PSNH. I wish good morning to you all. Now I am going to give a talk on today, nanotechnology and its applications. Please see here, before going to start the nanotechnology, first we are going to see some charts here available. Please see here some tables. Unifying principles or universe. In general, the universe having two components. The universe having two components. One is matter, second one is radiation. The matter exists in the universe in three forms: solid state, liquid state, and gaseous state. Whereas the radiation exists in two forms: invisible, visible form. We know very well about the visible form means colored: violet, indigo, blue, green, yellow, orange, and red. Invisible we know very well: gamma rays, X-rays, ultraviolet, infrared, microwave radiation, radio frequency radiation. These are the existence of the radiation, invisible radiation in the universe. Next here, the existence of the molecules in the universe. The existence of the molecules in the universe, three categories: macromolecules, micromolecules, and nanomolecules. Macromolecules means we know very well about the macromolecules. All the biological molecules are best example for the macromolecules, lipids, proteins, etc. Examples for the macromolecules. Whereas micromolecules example simple molecules, hydrochloric acid, water, acetic acid. All the simple molecules are examples for the micromolecules. Whereas nanomolecules means the size of the materials that exist in the 1 to 100 nanometers level. These are the examples of the nano level of the materials. See here, nanotechnology. Here I am going to give in one figure. This is called as carbon nanotubes. Today, overview of our presentation: introduction of nanotechnology, classification of nanomaterials, properties of nanomaterials, synthetic methods, instruments for characterization of nanomaterials, general applications, medical applications, my research work, and conclusions. These are the today overview of our presentation. Now see here, introduction of the nanotechnology. Why the majority of the researchers, they are interesting towards the nanotechnology. In general, the nanotechnology is a very small, very powerful, many applications and rapid research growth today. The first one, the nanotechnology is first proposed or presented by a famous physicist, Dr. Richard, in 1959. He was proposed first time the nanotechnology. The term nanotechnology had coined by Nario in 1974. Invention of scanning tunneling microscope in 1981 for discovery of the fullerenes. It leads to the emergence of the nanotechnology. So what is the nanotechnology? So the nanoscience and nanotechnology deals with the study of objects and systems in which at least one dimension within the range of 1 to 100 nanometer level. Next one, the term nano is taken from Greek word. Nano means little old man or dwarf. So nanometers play a significant role in science and technology due to their unique shape, size, and peculiar properties and wide range of applications. Nanotechnology, nanomaterials are differ from the bulk material, differ from the normal material. Now let us see here, what is the definition of nanotechnology? Nanotechnology is the creation and utilization of the materials, devices, systems, objects through the control of matter on the nanoscale. The nanotechnology is the creation and utilization of materials, devices, systems, and objectives through the control of matter on nanoscale. Now see here, classification of nanomaterials. The classification of the nanomaterials are four types: zero-dimensional nanomaterials, one-dimensional nanomaterials, two-dimensional nanomaterials, three-dimensional nanomaterials. Here available some of the figures about the one-dimensional, zero-dimensional, two-dimensional, three-dimensional available. Now I am going to explain clearly one by one about the all the categories of nanomaterials. Now let us see first classification of the nanomaterials are zero-dimensional nanomaterials. The materials are without the dimensions are called as zero-dimensional nanomaterials. The best example for this category of best example, nanoparticles are best example for this category. Next, see here available one of the image available. This is the TEM image, transmission electron microscopic image. Here all the particles are spherical with a smooth surface because of there is no dimensionless material. These particles are dimensional less particles. So smooth surface particles available here in the image. So here the nanoparticles, these zero dimensional nanoparticles are exist in the form of amorphous nature or crystalline nature. It is available in the form of crystalline nature or polycrystalline nature. Next one, these zero-dimensional nanometers best example, metallics also available, ceramics also available, polymerics also available for this category of zero-dimensional nanomaterials. Now, second classification, one-dimensional nanomaterials. One-dimensional nanomaterials means the materials that exist in one-dimension scale are called as one-dimensional nanomaterials. The best examples for this category of materials, nanotubes example, nanorods, nanowires are the best examples for this category. Here also these materials are exist in the form of amorphous nature or crystalline nature. It is also exist in the form of crystalline nature, polycrystalline nature. So the best examples of this category of materials are metallic, one-dimensional also available, ceramics, one-dimensional nanomaterials available, polymeric, one-dimensional nanomaterials also available. The classification of third category of materials are two-dimensional nanomaterials. The materials which are exist in two dimensions are called as two-dimensional nanomaterials. The best example for this category, nanofilms, nanolayers, and nano coatings are the best example. See here, available here, this is called as nano-coated films. Maybe here single coating or double coating or multi-coatings also available. These are called as nano-coated films. Here we have given one of the example, germanium SN nanofilms we have given. Here maybe single wall coating or double coating or triple coating also available. Here I have given some of the examples for this category. These are the materials examples of the two-dimensional nanomaterials. This is the coated material. These are the coated materials. These are the examples of the two-dimensional nano-coated materials. Here also these materials are exist in the form of amorphous nature, exist in the form of crystalline nature. Next examples of this category, metallics also available in 2D, ceramics also available in 2D nature, polymeric also available in 2D nano. Next, let us see the fourth classification is three-dimensional nanomaterials. The materials which are exist in 3D are called as three-dimensional nanomaterials. The best example for this category of nanoparticles, the dispersion of the nanoparticles are example, bundles of nanowires, bundles of nanotubes, multi-nano layers also best example for three-dimensional nanostructures. See here, I have given one of the example here. This is the multi-walled carbon nanotube. See here blue color carbon nanotube available, here green color available, here red color available, yellow color available. These are combined together. So these are called as multi-walled carbon nanotubes. These are the best example for the three-dimensional nanomaterials. Now let us see the properties of nanomaterials. Generally, the nanomaterials have high strength, hardness, formability, and toughness. Next one, these nanometers are exhibit elasticity in nature at low temperature. It is one of the specific property of nanomaterials. Next one here, the third property is very important for us. The size of the grains control the mechanical, electrical, optical, chemical, and magnetic properties. We are going to make desired nanomaterials. We are going to make desired objects based on our needs. This property is suitable. So why it is suitable for us? We are going to make the desired object with a specified mechanical properties, with a specific electrical properties, with a specific optical properties. We are going to make our needs of the material. That is one of the specification of this size of the grains. Next one, the melting point of the nano materials gets reduced on reducing the grain size. Grain size more, particle size heavier, the melting point is more, the particle size is less, the melting point also low for the nano materials. The magnetization and coercivity are higher for the nano materials. Now let us see here what type of methods are there for the synthesis of the nanomaterials or nanoparticles. Generally, the synthesis of nanomaterials are the three approaches are there: chemical methods, physical methods, and biological methods. Generally, these are the major classification of the synthetic methods or synthetic approaches for nanomaterials. Now let us see here. First one is chemical approach. Chemical approach also different types are there: chemical reduction, co-precipitation, microemulsion, sol gel, hydrothermal, and polyprocess. Already I have published papers in hydrothermal also. I have published by the chemical reduction methods also. Now let us see here physical approaches. Physical approaches, sonochemical, sputtering, microwave radiation, laser ablation, gamma irradiation, thermolysis, thermal decompositions are there. So here recently I have published one paper by microwave radiation method. So here, what are the drawbacks by using of these two methods for the production of the nanomaterials or for the fabrication of the nanomaterials? It is a costly techniques and conventional. It's a time-taking process. These are the drawbacks of the chemical approach and physical approach. Next one here, it is harm to the environment. We are going to prepare nanoparticles or nanomaterials by using chemical approach, physical approach. It harm to the environment. The last approach is biological approach. We are going to prepare, we are going to synthesize nanomaterials by using biological methods. Means we are going to use plant extract. What are the examples of the plant extract? Maybe leaf extract, bark extract, root extract, fruit extract, seed extract, flower extract. We are going to use as a precursor for synthesis of nanomaterials. These are called as biological process. Or we can use phytochemicals also for the synthesis of nanomaterials. Algae we can use, fungus we can use, bacteria also we can use. These are the living cells also we can use for the synthesis of nanomaterials. So these approaches are called as biological approaches. What about the advantage of these biological approaches? It is a very simple, low cost, non-toxic, eco-friendly. It is a good method. These are the advantages of the biological approaches. Now see here, what are the characterization techniques needed for the nanomaterial? After synthesis of nanometers, we are going to characterize. So what type of instrumental analysis need for characterization of nanomaterials? First one is ultraviolet visible spectrophotometer, FTIR, Fourier transform infrared spectroscopic analysis, powder X-ray diffraction analysis, scanning electron microscopic analysis, transmission electron microscopic, and zeta potential. These instrumentations are required for the characterization of the nanomaterials. First, let us see here UV visible spectrophotometer. So, what is the importance of the UV visible spectrophotometer for the characterization of nanomaterials? Generally, the UV visible spectrophotometer is a primary investigation tool where the nanomaterials are formed or not, we are going to finding by using UV visible spectrophotometer. It is a primary tool. Second one, Fourier transfer infrared spectroscopy. We are going to prepare the nanomaterial by using a plant-based material. So we are going to analysis by using FTR. So first we are going to take the FTR graph of the uh, biological material. After binding with the nanoparticle, we are going to check the what happened, the deviations of these two graphs. We are going to comparison by using Fourier transform infrared spectroscopy. XRD, X-ray diffraction analysis, it is used for the calculation of the particle size as well as we are going to finding the crystal nature of the nanoparticles we can find by using crystal order X-ray diffraction analysis. Scanning electron microscopy, one of the very important tool. The scanning electron microscopy used for the, we can find out the morphology of the nanoparticle. We can find out the morphology of the nanoparticle as well as what type of nanoparticles available in the material also we can find out by using SIM-IDAX. By SIM-IDAX, we are going to obtain the peaks concerned elements. Next, transmission electron microscopy. It is a powerful tool. So by using of this transmission electron microscopy, we are going to obtain the nanoparticle size and shape. Clearly, we obtain by using transmission electron microscope. It is also one of the good instrumentation to finding the size and shape of the nanoparticles with good images. Next, last tool of this one, zeta potential. We are going to calculate the stability of the nanoparticle and we can find the stability of the nanoparticle by using zeta potential, or this is called as dynamic light scattering characterization. Now let us see the applications of the nanotechnology. See here, so many applications are there in general, nanotechnology, the energy also, application energy, medicine and drugs, nanobiotechnology, nano devices, optical engineering, defense, security, bioengineering, cosmetics, nanofabrics. These are the general applications of the nanotechnology. Now let us see here application of the nanotechnology in various fields. Here I have given civil engineering applications, mechanical, electrical, medical applications of the nanomaterials or nanotechnology. Now let us see various applications of the nanotechnology in civil engineering as well as mechanical engineering. The construction engineering, nowadays what happened, we are going to making of the bricks by using of the nanotechnology. We are going to make a bricks by using normal cement materials. That strength is different. We are going to use the gypsum nanoparticle for making of the bricks, for making of the concrete. The life of the building also enhanced, the more strength for the uh, uh, building as well as increase the life of the building and the strengthening of the building also. It is the application of the nanotechnology in construction. Next, environmental engineering. Any water treatment for water plants polluted by the environmental, the environment polluted by the industry also, we are going to solve the environmental problems by using nanotechnology. Geotechnical engineering also applications, water resources engineering, materials engineering, structural engineering. These are the various applications of the nanotechnology in civil engineering. Whereas in mechanical engineering, structural materials, we are going to make the desired materials. Nowadays, we know very well the mechanical engineering, they are in advance in up to nano composites because of only nanotechnology applications. Next, nano devices, we are going to prepare nano devices and we are going to prepare nano sensors by using nanotechnology by the mechanical engineers. Next, coolants, the making of the coolants, heat spreaders and lubrication, also one of the good application by nanotechnology. Engine emission reduction. Now recently majority of the researchers they are working on reduce the engine emission by applying the nanotechnology. Next, fuel cells and battery storage, sustainable energy generation, photovoltaic cell. Nowadays, the photovoltaic cell is a hot topic for the researchers because we are going to prepare uh, Nano prepare the photovoltaic cell by using inorganic materials. By using of inorganic materials is also good for the photovoltaic cell making, but some drawbacks are there. The efficiency are very less, the life also very less. Nowadays, recently, the majority of the peoples they are working on nano photovoltaic cell or the solar thin films for fabrication of the photovoltaic cell. It will increase the storage capacity, increase the efficiency, increase the life of the material. It is one of the application from the nanotechnology biomechanical. Next, for the making of the nano composites, it is a very hot topic today. Nano composites, the majority of the defense equipments as well as aerospace equipments we are going to make by using nano composites, lightweight, more strength, high thermal stability, applications are there by usage of the nano composites. These are the mechanical applications. Now let us see here electrical applications. The nanotechnology and electronic components, especially transistors. The electrical people, they are completely depend upon the transistors. Previously available, the size of the transistors are more. Nowadays, it is a size is very less, the capacity is more, the life is more. These are the applications of the nanotechnology. Next, the electrical people, they are going to use some chips. The chips density increases. By increase the density of the chips, what happened? The memory of the chips also increases. Decrease the weight of thickness of the screens also. Previously, we know very well a big computers are there. Now it is available a small computers, small laptops because of only the nanotechnology. Fabrication of the chips also by using nanotechnology. The fabrication of the chips means increase the storage capacity and reduce the size of the chips by using of nanotechnology in electrical applications. Whereas in medical applications, especially the nanotechnology, very important in medical, cancer treatment, bone treatment, drug delivery, drug development, making of medical tools, diagnostic of tests, as well as imaging. These are the various applications of the nanotechnology in medical field. Now see here, I have given some of the examples here. The biomedical applications in drugs, medicines, therapeutics, in diagnosis of disease, abnormal conditions, in surgery, in medical robots, robotics, increasing knowledge on human body. These are the biomedical general applications. Now today, I'm going to give a special talk, especially on the what is the importance of the nanotechnology on cancer therapy. So this is very important. Generally, we have seen the entire world, the death of the population, 1/4 of the death of the population because of only cancer. It is a very severe problem. So, what about the key role of the nanotechnology in cancer therapy? Generally, we know very well the different types of cancers available: the skin cancer, bone cancer, bowel cancer, breast cancer, prostate cancer, lung cancer, like that. Different types of cancers are available. So, what happened? What are the general treatments for the cancer? Generally, different types of therapeutic approaches are there for the treatment of cancer. Surgery is there, radiotherapy is there, chemotherapy is there. Among these, the best one is chemotherapy is a best for cancer treatment compared to remaining surgery and radiotherapeutic methods. So what happened by radiotherapeutic method, our body is not exist, not support for the radiotherapeutic approach in sometimes is a problematic. So the chemotherapy is a best treatment for cancer. So here we are going to see here by chemotherapy means they have given the drugs. We have taken anti-cancer drug by orally is called as chemotherapeutic approach. We are going to take the tablets, the drugs by orally is called as chemotherapy. So by taking of these drugs by orally, what happened? The normal drugs kill the cancer cells as well as damage the healthy tissues or healthy cells in a body. It is a drawback of chemotherapy by taking of normal drug. So here it is a severe problem. So what happened? The drug will affect on cancer cells as well as nearby the cancer cells. The healthy cells as well as healthy tissues also damaged by chemo by using a normal drugs. So what about the application? What are the application and advantages of nanotechnology? We are going to establish, we are going to develop nanotechnology targeted the affected area, especially the releasing of drug at affected area at cancer site. The nanotechnology will effectively works. It releases drug only targeted area. It destroy only affected cells. It destroy only cancer cells. It will not affect on normal cells. So it minimize the side effects. No harm to the healthy tissues. No harm to the healthy tissues by nano drug delivery. It is one of the very important application. See here different. Here one image. It is my one of the paper now. It is going on my project funded project. See here drug delivery for cancer treatment. See here this drug delivery is called as in vitro studies. We are going to do the clinical trials without the animal. We are going to do only in chemistry lab or any lab. These methods are called as in vitro clinical trials. The in vitro clinical trials means without animal. We are going to do trials by using medicines are called as in vitro treatment. See here my work. We have prepared gold nanoparticle. This Hari chloride is the material of the gold. We are going to use some natural gums. Here, natural gum is frankincense resin. So by using of these two, by the hydrothermal process, we have prepared gold nanoparticles. These gold nanoparticles loaded by the drug. The drug name was here, the drug is called as doxorubicin, one of the anti-cancer drug, doxorubicin. So this drug is loaded here with nanoparticle. So generally it is having a fluorescence activity. This drug having fluorescence activity. When adding of this drug to the loaded by nanoparticle of here fluorescence activity stopped for the drug. Now see here the drug loaded nanoparticle. Here the nanoparticle act as a good carrier. So the releasing of the drug at a particular pH level. So we know very well the pH of the cancer cell is 6.5, 5.5 to 6.5. The affected cancer tissue pH level is 5.5 to 6.5. So what happened? The pH dependent, the gold nanoparticle especially release the drug at a particular pH level. These pHs are there in a cell. It directly release the drug on a particular pH level. That is the capability of the gold nanoparticle. Second one, why we have choose only gold as a good nanomaterial for the delivery of the anti-cancer drug, especially it is having a sensing capacity. It can detect the sensing the affected tissues. That is one of the specified property of the gold nanoparticle. This is called as in vitro studies. Now let us see here, attacking of nanoparticles on bacteria. It is very important for us, attacking of nanoparticles on bacteria. Before going to discuss about the attacking of nanoparticles on bacteria, first we are going to see about the multi-drug resistance. Is one of the major problem. The entire world they are suffering with the multi-drug resistance. What is the multi-drug resistance is a small doubt for you. Generally the multi-drug resistance is what happened. We are going to taking excessive antibiotics. We are going to taking excessive antibiotics, or we are going to taking inappropriate antibiotics. What happened in the body? The bacterial cell resist drug. The bacterial cell resist drug. These are called as multi-drug resistance. What happened? We are going to take 200 mg of the drug. It will not affect because of multi-drug resistance of the bacteria. So we are going to enhance the dosage. These type of problems happen. These are called as multi-drug resistance. Generally, how it happened by the multi-drug resistance for a drug? See here, for example, the attacking of we have taken for we are suffering some fever, some many health issues. So we are going to take antibiotics by the suggestion by the doctor. What happened? Doctor has given antibiotic for us. We have taken antibiotics by orally. What happened? The antibiotics, how the destroy the bacterial cell or bacteria by antibiotics. The antibiotics attacks target bacteria in three different approaches. Three different approaches, not a one approach. The attacking of antibiotics on bacteria, three different approaches. The first approach is cell wall synthesis. Generally see here, the bacterial cell having cell wall. The every bacterial cell, virus cell having cell wall. So the attacking of antibiotics on cell wall synthesis. What happened? The antibiotic attack on cell wall, it is bind with the cell. What happened? There is no functioning. So dysfunction of the cell by attacking of bacteria on cell wall. This is one type of approaching of attacking of antibiotic on bacteria. Second one, DNA replication machinery. DNA replication machinery means what happened? The antibiotic enter into the inside of the bacterial cell. So it is a bind with the DNA. Bind with the DNA, what happened? No functioning of the cell. Dysfunction of the cell by the binding of the antibiotic with the inside of the DNA of the cell. This is the second way approach of the antibiotics attack on the bacterial cell. The third way is translational machinery. What happened? There is no replication process. Generally, what happened? Today, 100 bacteria are there. Tomorrow, it will be 1,000. After 10,000. Like the day by day, what happened? The bacterial are growing inside of the body. So these processes are called as translational machinery or replication process. This process has been stopped by the antibiotic by third method. So what about the variation of the attacking of the nanoparticles on bacterial cell wall or virus cell wall? What is the differentiation between these two? Generally, the nanoparticle attacks on directly on cell wall. That is the specification of the nanoparticle. The nanoparticle directly attacks on the surface of the bacteria, or directly attacks like a blasting. It directly attacks on the surface of the cell wall or virus cell. Here what happened? The attacking of nanoparticle directly on the surface of the bacterial cell or cancer cell, it is penetrate into inside of the bacterial cell, inside of the virus cell. It directly penetrates into inside of the cell or inside of the bacterial cell. So here different types of the nanoparticles are there during the making of the nanoparticles. So the small nanoparticles directly penetrate into inside of the cell. The big size nanoparticles are retained on the surface of the cell wall or retained on the cell wall. It is binding with the cell wall, binding with the cell wall. The smaller nanoparticles enter into the inside of the cell wall. So here what happened here? The cell wall, by attacking of cell wall on the surface of the bacterial cell, on the surface of the viral cell, the surface of the bacterial cell is having proteins, or the protein coated thin wall is there. The protein coated thin wall completely leaked. The leakage of the cell wall, the protein content was leaked by attacking of the nanoparticle on cell wall. The penetration of the small particle inside of the cell wall, either virus cell or bacterial cell. Here, the binding of this small nanoparticle with different structures of the inside of the cell wall. It is binding with the DNA structure, DNA. Binding of the DNA means here dysfunction of the DNA. Here binding with the enzyme, so dysfunction of the enzyme. Binding with the cytoplasm, binding with the ROS, binding with the ROS, binding with the uh, ribosomes. So these are the inside mechanism of the nanoparticle. So finally what happened? The total total cell is completely dysfunction, destroyed by the nanoparticle. It is a special mechanism of the nanoparticle. So this is the reason for the majority of the people nowadays, they are going to use only nanotechnology for treatment of cancer. Now see here, I am going to explain one of the best example, drug delivery for cancer treatment. See here, here we have taken gold nanoparticle. Already I told what is the importance of the gold nanoparticle. The property of the gold nanoparticle having the sensing property. It has sensing application. Because of that reason only we are going to choose as a good carrier for cancer therapy. The gold nanoparticle choose as a good carrier for anti-cancer treatment. So here we have taken gold nanoparticle. The gold nanoparticle here loaded by the drugs. So this is the drug covered by the gold nanoparticle. See here how to attack this gold nanoparticle along with the drug on cell wall or cancer cell. This is the cancer cell. See here, this is the cancer cell. It is having a, thick coated protein content on the cell wall. So it is directly attacks on the surface of the cell wall. After then, it is penetrate inside of the cell. What happened? These nanoparticles, these drugs are released by the nanoparticle. This releasing of the drug set directly approaches, directly bind with the nucleus, directly bind with the nucleus and inhibit the dysfunction of the total cell. This is the mechanism of the drug delivery of uh, uh, cancer therapy by using nanotechnology. See here, one of the example I have given here is the best example for the drug delivery for cancer treatment. This MDR means multi-drug resistance. MDR means multi-drug resistance. Now see here, the another biomedical application, the machines, small nano machines available, the tooth cleaning using smart nano machines available. The smart nano machines, what happened, clean the tooth. These are the one of the biomedical applications from nanotechnology. The another application here, cleaning of the lungs. Cleaning of the lungs. Generally, what happened? The mucus is formed inside of the lungs. So means what happened? We're suffered by more mucus is formed inside of the lungs. What happened? We are suffering from asthma and some respiratory problems also happened by the completely uh, full mucus are there inside of the lung. What happened? Affected by the we are affected by asthma and some respiratory problems. See here what happened. These machines also, the robots, lung cleaning robots also what happened, it entered into the lungs and cleared the all the mucus. That is one of the applications by nanotechnology. Now let us see here another one. Tiny robots can clear clogged arteries. Generally, what happened due to a presence of heavy fat in our human body, what happened? It causes for the formation of the cholesterol in a blood. What happened? Cholesterol means what happened? Increase the thickness of the blood of the human body. What happened? There is no proper pumping. Uh, there is no proper pumping. No proper pumping means what happened? The clots are formed in arteries of the nearby hearts. What happened? It leads for the heart attacks, cardiac arrest. Also one of the big problem today. See here by using of this nano robots, tiny nano robots. What happened? It cleared the blood clots in a arteries by using of this nanotechnology. It's a hot topic today in entire world about the nano robots for the cleaning of the arteries, cleaning of the blood clots in a arteries. Now let us see what are the different biomedical applications of the nanomaterials. Here see I have taken one of the gold nanoparticle. We are going to detection of the hazard agent. We don't know. We are going to take water from raw water in different areas like that rivers and ponds. We don't know what about the contaminants are there in a water. We are going to finding the hazard agents in a water by using gold nanoparticles. Second one, we are going to finding the toxic elements in water sample, either sewage water, either pond water, river water, any water samples we are going to take and we are going to finding the toxic elements also by using nanotechnology. Next one, pesticide drug. For example, agriculture people they are going to use the pesticides. What happened after usage? They are going to release these pesticides nearby the water bodies. The nearby water bodies contaminated by these pesticides. What happened? The water is contamination by the pesticides. By using nanotechnology, these pesticides we are going to dissect, removal of these pesticides by using nanotechnology, as well as we are going to finding how much concentration of the pesticides present in a contaminated water also we can find it. Next one, veterinary drugs also, detection of the veterinary drugs also in contaminated water also we are going to use gold nanoparticle as a application. Next one, detection of heavy metals. We know very well about the Hyderabad. The Hyderabad, we are going to take water from Moosi River and different rivers are there. The contamination of the industrial effluents, what happened by the contamination of these water bodies by industrial effluents, what happened? It has so many elements are there. We are going to detection of the heavy elements, heavy metals, either inorganic metals or organic ions, any ions, either metallic ions or organic ions and inorganic ions, we are going to by using nanotechnology as one of the good application detection of the heavy metal ions in wastewater or contaminated water. Now let us see here, I am going to explain one of my research work published in chemical papers. See here, the first one, synthesis of gold nanoparticles by hydrothermal method. Now see here, before going to start the synthesis, what is the hydrothermal method? Hydrothermal method means we are going to synthesize nanomaterials by using heating devices are called as hydrothermal method. Maybe we are going to use magnetic stirrer with hot plates also. We are going to synthesize material, that is also hydrothermal method. We are going to synthesize nanomaterials by using chemical bath method also hydrothermal method. We are going to synthesize nanomaterials by using autoclave also hydrothermal methods. Finally, we are going to preparation of the materials by using heating devices are called as hydrothermal methods. See here in my work we have taken this gum. Gum is called as gum kondagogo. So in this work I have taken this gum. This gum is modified to carboxymethyl gum kondagogo. What is the carboxymethylation means? Generally it is having some functional groups. I am going to add here the methyl group to a gums, that is called as modification of this gum to carboxymethyl gum kondagogo. This is called as modification. Generally I have done this work by using chloroacetic acid. I have used as a chemical for the modification of the gum kondagogo to carboxymethyl gum kondagogo. After conversion of this after conversion of this gum kondagogo to carboxymethyl gum kondagogo, I am going to making up the gold nanoparticle by using Hari chloride. Hari chloride means we have prepared 2 millimolar concentration of the Hari chloride solution I have prepared for this work, and then I have taken fine powder of carboxymethyl gum kondagogo 1 gram I have taken. I have dissolved in a hot water and maintained stirring the reaction mixture 6 hours. After 6 hours, I have taken the solution. The solution transferred through the Whatman paper. Thus, these two solutions I have mixed in a ratios 4 is to 6, 5 is to 6 like that. I have made the solution. After then, the solution I have keep in autoclave. The red color solution often is called as nano gold solution. Nano gold nanoparticle, colloidal gold nanoparticle solution we obtain. So this colloidal gold nanoparticle solution I have used for the as an antimicrobial agent for the biological applications. Second one I have used for the catalytic application of 4-nitrophenol converted into 4-amino phenol. I have investigated by using this gold nanoparticle. It is one of the catalytic application. It is one of the biological application. Now see here, what is how we are going to prepare nanoparticles by using gold and gum solution. See here, this is the UV visible spectroscopic analysis. Here generally, this is the first one. First figure indicates the here what happened. Increase the concentration of the gum solution. Gum solution increase here 0.1 percentage, 0.2, 0.5, 0.7, 1% like that. Increasing of the concentration, whereas the gold solution was constant. Gold solution was constant. Here, the gum concentration increases 0.1 to 1 percentage. See here after this is called as optimization studies. This is called as optimization studies. See here what happened here 0.1 percentage. I obtained the peak at 520 nanometers. It indicates the formation of the gold nanoparticle. At 520 nanometers, the absorbance is very less here, only 0.3 percentage of the absorbance here. The intensity are very less. Now I am going to increase here concentration of the CMGK, increase the intensity of this peak, increase here, increase here, increase here. Up to 1%, here the intensity of the peak increases. Whereas increase the more concentration, there is no further increasing of the peak. So it indicates the maximum nanoparticles are formed at 1% of the CMGK. It is one of the optimization study of the preparation of the nanoparticles. Now let us see here, the second figure indicates here, the gum solution was constant, whereas here the gold solution concentration increases. See here, 0.1 millimolar, 0.2 millimolar, 0.5 millimolar, 0.7 millimolar, 1 millimolar of the concentration of the hydrochloride solution. See here, the intensity less at here, the peak here only intensity very less, maybe 0.3 absorbance at 520 nanometer. The intensity are very less. I'm increasing the concentration of the gold solution, increase intensity, increase the intensity, increase the concentration, intensity of the peak, intensity of the peak. So it concluded what happened by increasing of the concentration of the gold solution, by increasing of the concentration of the gum solution, the formation of the gold nanoparticles also increases. More gold nanoparticles are formed by increasing of concentration of the gum as well as increasing of the concentration of the gold solution. Now let us see third parameter for the optimization of the synthesized material. See here, we have time autoclaving time here. I have given here autoclaving time here 5 minutes, 10 minutes, 15 minutes, 20 minutes, like that I am going to increase. Here 5 minutes, what happened, the intensity is less, the formation of the materials are very less. Increasing the time, formation of the gold nanoparticles increases. By increasing of the time in autoclave, what happened, the formation of the gold nanoparticles increases. Intensity of the peak increases indicates the formation of the nanoparticles also increases. More nanoparticles here formation. Now let us see here another example, the Fourier transform infrared spectroscopy as well as zeta potential. See here, the Fourier transform infrared spectroscopy here. Here two peaks are there. The first one is called as the carboxymethyl gum kondagogu peak. The second one is the carboxymethyl stabilized gold nanoparticle. So the CMGK capped gold nanoparticle. See here what happened. These peaks are different. The gum FTR peaks are different, whereas the CMGK capped AMPS peak are different. What happened? The peaks here shifted, changing of the original peaks of the natural gum. It indicates the binding of the natural gum with the gold nanoparticle. Effectively, the gold nanoparticles are effectively stabilized by gum solution. This indicates the second graph from the FTR. Second one, zeta potential. It shows the stability of the zeta potential based on the values here. We obtain the negative value minus 19 volts. It indicates the stability of the gold nanoparticles. Now see here, XRD, X-ray diffraction analysis. This is the XRD obtained from the XRD spectrum. So here we have seen here different peaks are there. 111 orientation peak is there, 200, 220, and 311 peaks are there at different theta values. We obtain different peaks here. See here, the 111 is orientation is intensity is maximum compared to remaining these three. So we don't believe this is a suitable for. We cannot believe directly by using this figure. It is a gold nanoparticle. How we are going to believe this one? We are going to compare a standard file is available. The standard data is available. We are going to compare the standard file. Standard file means the JCPD, the Joint Commission Powder XRD file is there. They have given some data. Based on the data only, we are going to compare our graph with that one. Then only we are going to agree here the formation of the form the gold nanoparticle or not. We are going to conclude by using only comparison of this graph with a standard data. This is the XRD analysis. Now see here, transmission electron microscopy here, MEMS here available. See here, this is the Temimase, here Temimase, here this is the seed diagram. This is the distribution of the nanoparticle. For my gold nanoparticle, here obtained the maximum nanoparticle at 11 to 14 is the maximum nanoparticle. The maximum nanoparticle has formed at 11 to 14. Size of the particles are more compared to remaining nanoparticle. The least nanoparticle size here 7. The highest nanoparticle size here 6. This is the distribution of the nanoparticles and TEMIMACE. So by the TEMIMACE, we are going to obtain size of the nanoparticles. See here, the spherical size available here. The spherical size of the nanoparticles, maximum spherical size only available. Some little bit only deviate from its spherical. The maximum of the nanoparticles here, spherical size. Now see here, another investigation from this, my research work, see here. Generally, we know very well this reaction. The para-nitrophenol is converted to para-amino. It's a general reaction. So what happened? We have done this reaction by using sodium borohydrate also. It's take more time. So what about the comparison of this reaction with the gold nanoparticle? Now see here, this is called as para-nitrophenol solution, colorless. Here see here, para-nitrophenolate ion solution. This is called as intermediate. This is called as final product, para-aminophenol. The para-nitrophenol converted to para-aminophenol. This is the reaction we are going to investigate it. We have investigated by using our prepared nanoparticle. Now see here, we have taken this solution. This is a para-nitrophenol solution. To the solution, we have added sodium borohydrate solution. Added sodium borohydrate solution. What happened? This hydroxy group of this phenolic group loses H plus here, the formation of the O minus ion. Now it is called as 4-nitrophenolate ion. It is a intermediate. Here the solution color also changes. Now here see how we are going to find whether the solution is colorless. It shows the 317 nanometers. 317 nanometers. The solution shows on UV visible spectrophotometer 317 nanometers. See here, this is the peak, A peak. The A peak indicates the 4-nitrophenol. The 4-nitrophenol peak at 317 nanometer in UV visible spectrophotometer. Now let us see here. After adding of sodium borohydrate to a 4-nitrophenol, formation of the 4-nitrophenolate ion. Here formation of the 4-nitrophenolate ion at 400 nanometers. See here, the intensity also more intense. The intensity is maximum, high intensity, nearly 2.2 or 2.3 intensity of this peak here. See here, it indicates the formation of the 4-nitrophenolate ion, as well as here the color also one of the indication for us. Now see here, there is no conversion of this 4-nitrophenol to 4-aminophenol without the nanoparticle. Now we are going to take the solution. To the solution, we are going to add here added gold nanoparticle. By adding of gold nanoparticle to the solution, formation of the 4-aminophenol within the minutes only, 1 or 2 minutes, maximum 4 minutes only, it converted to 4-aminophenol. So how we are going to finding this one? See here, initially here the peak intensity is more. 0 minutes, the peak intensity is high. By increasing of the time, what happened here? The reduce the intensity of the peak. See here, intensity is decreased, decreasing of intensity, decreasing of intensity, decreasing of intensity. After 17 minutes, what happened? The 4-nitrophenolate ion is completely converted. The 4-nitrophenolate ion is completely converted to compound 4-aminophenol. It is converted to 4-aminophenol. This is the conversion of the 4-aminophenol. This is the evidence of this investigation by using UV visible spectroscopy. Now let us see here the conclusions of the nanotechnology. Conclusions of the nanotechnology. Nanotechnology will radically change the way we diagnose, prevent the people from the cancer disease, and eliminating the cancer effect on human beings by the help of the nanotechnology. Nanotechnology is a promising area of research with potential benefits in a patients suffering various illnesses. Next one, very interesting application of this nanotechnology. Nanorobots used for microsurgeries on any part of the body. Any part of the body we are going to use nano machines for surgery. It is one of the good application by using nanotechnology. These minute instruments would be precise and accurate, targeting only the area where surgery should be done, less chance to any mistakes or faults. So by using of nanotechnology, there is no any problem for the human beings by using applying the nanotechnology. Next one, surgery could also be done on tissue level, genetic level, cellular levels also. We can make surgery by using nanotechnology. Next one, replacing of abnormal genes. What happened due to presence of the some genetic codes in our body causes for some chronic disease, and we are going to change the gene code as well as we are going to modify the gene. We are going to replace the genes also by the help of the nanotechnology. Is one of the good application in medical field. Nanotechnology future jobs. Generally now in entire world, nearly more than 20,000 of peoples, not only more than 2,000, maybe I think nearly 50,000 peoples are working on nanotechnologies in various universities and colleges for the finding of the different solutions for the problems, and they are going to give benefits to the society also. They are working now. Second one in education. What about the education, the field of education, nanotechnology? In university level as well as college level, some of the faculty they are working on nanotechnology. They are publishing papers. These papers are facilitated for the future generation of our society. It is helpful for them. That is one of the education importance of the nanotechnology. The nanotechnology will solve the any problem in the society by the help of the nanotechnology. It is a good example, the application of the nanotechnology. Manufacturing, the factory workers may utilize the principles of nano technique for the fabrication of different materials, especially for consumer materials, industrial products we are going to make by using nano applications are very important nowadays. Now, engineers, they can apply nanoscience to consumer electronics, medical equipments, artificial organs, and thousands of other devices developments nowadays. The need of the nanotechnology by engineers. The medicine, the nanomedicine develop effective ways to deliver the drugs, fight cancer, perform surgery, target specified cells, improve the health of the people around the world. The second very important by the nanomedicine, what happened? Generally, the doctor prescribed for medicine for us, maybe I think 500 mg to 50 mg. By applying the nanotechnology, only enough 20 mg. So what happened? We are going to reduce the dosage of the drug, one of the good application by development of the nanomedicine. Second one, reduce the side effects, reduce the severe side effects, reduce the maximum side effects by using nanotechnology also, one of the good application. Now, the effectiveness, the drug work inside of the body also effectively, these are the specified applications of the nanotechnology in a medicine. Business maybe in future what happened, the majority of the MBA people they depend on nanotechnology because of nowadays available from clothes to computer and medicine. So many uh, inventions are going on nowadays on by using of nanotechnology. These are the future jobs of the nanotechnology. Thank you.
So
Yes,
thank you,
sir.
sir. Sir, thank you, sir,
Thank you,
for
sir.
your valuable session on nanotechnology. I think this it will be very helpful for the faculty members or the students who are doing research on this area. Because of some technical issue, we are unable to conduct question and answer. If you have any question or any queries, please post on the WhatsApp group. Sir will answer today or tomorrow. And at the end, today we are and in WhatsApp group also we will provide a feedback form. Just fill the feedback form. At the end, you will get a certificate to your email address. Now I will hand over to Mukesh to give vote of thanks. Mukesh. Mukesh. And certificates we can provide only for 100 members because the limit is for 100 members. Don't worry, tomorrow also we can give for all the participants, those who are registered or those who filled the feedback form, we can give the certificates. So per day only 100, today we can give only 100 certificates, and tomorrow remaining for every member, for every those who are registered, everyone get the certificate. Thank you. Mukesh, you can join now. Mukesh, 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 start it. Chep. Okay, due to some technical issue, we are unable to connect Mukesh. So thank you for all the participants. If you have already, I told you, if you have any queries, please post on that WhatsApp group. And thank you, Konda Reddy sir, for giving your valuable presentation. And future also, sir is going to conduct more webinars on this nanotechnology, and he want to present his research ideas also. So thank you one and all. Thank you everyone. So we are going to end this session. Thank you. Thank you, everyone.
Okay, thank you, sir. Thank you.
Thank you.